Bismillahirrahmanirrahim. In this video, we will discuss about the nature of roots of quadratic equation. We all know that the standard quadratic equation is written as ax square bx plus c equals to 0, and we use a formula to find its roots or its values. This formula is called quadratic formula, that is minus b plus minus b square minus 4ac under root over 2a. This is called quadratic formula. Today our point of discussion is that without solving an equation, how we can determine the nature of roots of a quadratic equation without solving. So to find its roots, this part which is enclosed within the radical sign, this is called discriminant. And we shortly write it as disk, and this part b squared minus 4ac actually decides the nature of the roots of the quadratic equation. So there are four possible options. First one is if b square minus 4ac's answer is positive, and a perfect square, then roots will be, or roots of equation will be rational, and every rational number is called a real number, and roots will be unequal, or you can say two different values of x will be there from the equation if we will solve the equation. So the main point in this discussion is this, that if the value of b squared minus 4ac is positive, any positive number, and it is any perfect square, so then the roots will be rational, that means real, and roots will be unequal, means there will be two different answers. For example, if solution of b square minus 4ac is equals to 36, that means it is a positive number, and it is a square number as well. So this is about the very first point, that if the value of discriminant is equals to a positive number and a square number like 36, like 49, then roots will be rational, and those will be unequal, or two different values of x will be the solution of the variable. So the point number one is discussed, that the nature of the roots will be rational and unequal if discriminant is positive and it is a perfect square. Second option is, or second possibility, if discriminant is positive number, but not a perfect square. If it is not a perfect square, then the roots will be irrational, and again irrational means it will be real, and roots will be different. For example, if we have value of b square minus 4ac is equals to 7. This is for example. Now 7 is positive number, but it is not a perfect scale. So in this case, the roots will be irrational. So every irrational is also called real number. So positive roots will be irrational. This is the second case which I discussed. Now, if we discuss the third one, that states if discriminant, that is b square minus 4ac equals to 0, then roots of the equation will be rational and equal, and equal means identical, or it means same, all have the same senses. So it's very simple. If the value of the discriminant is equal to 0, then there will be actually same roots, means same values of x, or there will be only a single value of x, means for example, values of x will be like 4 and 4 from a quadratic equation. So the two roots will be there, but both of these two roots have equal answers. So these are called equal or same roots or same values of x. So this is the point number or possibility number 3. Now we will discuss finally the last one. So if discriminant value b square minus 4ac is less than 0, means that it is negative, then roots of quadratic equation will be complex numbers, or you call it as imaginary numbers. So for example, if we have b square minus 4ac equals to minus 3. So in that case, the roots will be complex. So let me tell you quickly what is meant by complex numbers. You people must have learned in grade 9 about the complex numbers. The complex numbers are of the form a plus iota b form. For example, such type of numbers 2 plus 3 iota or 2 minus 3 iota, these type of numbers which contains one imaginary number that is called iota, and this iota square was equals to minus 1. So just to recall which are the complex numbers or imaginary numbers, numbers which contains iota sign. I wanted to discuss about uh, types of numbers because these will be used in upcoming questions. I have introduced the word complex number or recall the complex number. One more thing also needs to be revised, which are the rational numbers. So rational numbers are the numbers which are in P over Q form, or any numbers, any decimal numbers which can be converted into P over Q form where Q should not be 0. Such numbers are called rational numbers. And for example, like 2, 1 by 2, 3, 4 by 3, all such type of numbers are called rational numbers. So the rational number is introduced very well in grade 9. So I have explained the word rational numbers. Now I wanted to recall irrational numbers. So irrational numbers are numbers which cannot be written in P over Q form, and for example, irrational numbers are like under root 2, under root 3, under root 5, under root 7. These type of numbers are called irrational numbers. So firstly, I have explained you the rational numbers, complex numbers, rational numbers, irrational numbers, and now finally the word real numbers. So real numbers are called, which is denoted by capital R, rationals and irrational numbers joined together to form a bigger set that is called real numbers. So you normally can say if rational number can also be declared as real number, and irrational number that is also will be declared as real numbers. So I hope that from this topic you will be able to understand that how we can, which criteria will be set to find the nature of roots of quadratic equation. In the next video, we will discuss about that how to find discriminant from numerical examples, and then we will also solve some questions to verify the results about the nature of the roots by testing discriminant first, and then by using this criteria which I have just explained you about the discriminant possible values, positive, negative, equal to 0, and positive but perfect squares. So 4 categories are there which I have just explained in this video, and we will apply all these 4 properties, or you can say the properties of discriminant, and we will apply them directly to the quadratic equations to test the nature of roots of quadratic equation without solving the equation, and then we will solve the equations in next questions to verify the nature of the results. So up to now you will be able to understand how will you find the nature of roots of quadratic equation without solving?